Special circumstances. Now let's discuss special circumstances of the FTC. What happens if the lower bound is a variable instead of a constant? For example, in this function of x, our lower bound now is the variable x. Using the property of integrals, we can flip the bounds, but then we need to switch the signs of the integral. For example, we need to make it negative. So you'll notice that we do switch the bounds. 5 is now the lower bound and x is the upper bound, and we made the integral negative. So what we can do now is replace t with x. So we do apply the fundamental theorem of calculus part 1, and we distribute the negative. So you notice that now f prime of x is equal to negative 4x cubed plus 1. Another special circumstance of the FTC is when the upper bound is not just x. Let's look at this scenario below. Here we have h of x is equal to negative 8 to 2x squared of 5t squared plus 6t dt. We want to find h prime of x. So we notice that the upper bound in this case is not a plain x, but it's 2x squared. One option is to use the FTC part 2 and then use the chain rule to differentiate. So you'll notice that we integrated or found the antiderivative of 5t squared plus 6t dt to get 5 over 3t cubed plus 6t squared divided by 2, as that is evaluated from negative 8 to 2x squared. The next thing we do is we actually go ahead and work through by replacing t here with 2x squared. And then we evaluate it a second time by replacing t with negative 8. What this gives us is we have h prime of x is equal to 4x times 5 times 2x squared squared plus 4x times 6 times 2x squared. Notice we have a 4x each time, so we factor the 4x out to get this expression down here. This is fairly time-consuming though. What relationship do you notice between the function and the derivative? So take a look up here at the function and take a look at the derivative. Do you notice any similarities? Did you notice that this yellow piece up here, 5t squared plus 6t, is simply the FTC part 1 by replacing t with 2x squared here and here. And it's also multiplied by the derivative of the upper bound, which is shown in green. The derivative of 2x squared is 4x. So essentially, we are applying the FTC part 1 and the chain rule if one of our bounds is a function other than x. There's one more special circumstance of the FTC. What happens when both the upper and lower bounds have variables? For example, given that f of x is equal to the integral from 3x to x cubed of e to the t power dt, we want to find f prime of x. The first step is to split the integral as shown. So f prime of x equals to our original function becomes the integral from 3x to 0 of e to the t dt plus the integral from 0 to x cubed e to the t dt. The next step is pretty clever. We use the property of integrals to reverse the bounds of the first integral in order to use the FTC part 1. So you'll notice that I reverse the bounds. Here we originally had 3x to 0. I reverse it, so we go from 0 to 3x, and I incorporate a negative. Finally, we apply the FTC part 1 and the chain rule due to the bounds being a function other than x. So we integrate from 0 to 3x of e to the t dt, which means I replace t with 3x, that's down here, and I find a derivative of 3x, which is 3. Next, I add to that the integral from 0 to x cubed, so I replace x cubed, I'm sorry, I said that backwards, I replace t with x cubed to get e to the x cubed, and then I differentiate x cubed and multiply by that, which is 3x squared. Finally, I simplify and rewrite it, so we're going to have f prime of x is equal to 3x squared e to the x cubed power minus 3 times e to the 3x power.